Clean here again. I'm going to do another quick video here on solving systems of equations, but this time it's a new method. It's called substitution, and this is actually an option for the last video where we were looking at equations like this one that weren't in the correct form and rearranging them into y form and doing equal values. But this method's an alternative to that. Okay. So it relies on having at least one of the equations in y form. So in this case, this top equation, this quantity is equal to y. And so here comes the substitution step. I'm going to take that quantity and I'm going to put it into this equation in place of y. And so it'll end up looking like this. I'm going to rewrite this bottom equation. And the bottom equation is going to become 2x equals 6 minus 2 times y. But now, instead of y, I can take this quantity and substitute it into the place of y. That's the substitution step. So now I have this equation, and it's just in terms of x. And if I solve that equation, that'll give me the x value of the point of intersection. So now remember, these two equations, they're both lines. And if we graphed them, I actually already did, if we graphed them, we'd see a point of intersection. It's right there. But this algebraic method's more efficient. So we're doing an algebraic method to find this point of intersection. And in this case, where the equations really aren't arranged necessarily in the best way. All right, so let's solve this equation. We're going to have to start by distributing this -2. So I'm going to rewrite 2x equals 6, and then a -2 times 3x's is a -6x's, and a -2 times 11 is a -22. All right, so I got rid of the parentheses. We'll add the 6x's over, and that'll take care of that term. And that'll give me 8x's. And I probably should have combined these. So I need to look at those terms. I've got a +6 and a -22. And that's going to give me a -16. So if we divide, I'm going to end up with x equals -2. So now we know that the x value of our point of intersection is at -2. All right, now it's going to be an awful lot like what we were doing before. We need to get the y value. And I think I'm going to choose to use the original equation that was in y form. I'm going to use this one. So y equals 3 times whatever x is, then plus 11. And I've got this x value from here. So that tells me that y is -6 plus 11, which ends up being 5. So that says -2, 5. All right. Now I should do a check. I need to use this original equation to do my check. And since I have an x value and a y value, I'm going to substitute them both in at the same time. So watch how this check works. In this equation, it says that 2 times x is supposed to equal 6 minus 2 times whatever y is. So now we can substitute those values in. The x is -2 and the y is 5. And we'll see if this works. -4. 6 minus 10. Yep, I think I believe that. So now that checks. So that means that this is our correct point of intersection. And if we look at our graph, that's actually what it predicted. Or if we'd solved it with a graph, that's the solution we would have gotten. All right, let's do one more really quickly, and then I will send you off to do your practice. Okay, so let's see. how about this? We'll say y equals the opposite of x plus 3 and 2x minus y equals negative 9. All right, whoops. So substitution step. Since the y is equal to that quantity, I can substitute in for y. Now, in terms of execution, there's a way you should try to do these. 2x minus, and it's a good idea to write parentheses in place of the variable you're substituting into. And that's going to give me a new equation, which after I substitute in for y, this equation is all in terms of x. And again, once we solve this, we'll have the x value of the point of intersection. All right, so let's solve here. Again, we're going to have to be careful. We're distributing a negative, so let's be really careful about that part first. This term's not going to change. The opposite of a negative x is a positive x. The opposite of add 3 is subtract 3. And then we can combine, so that's really, and we'll add, and that's going to get me that 3x equals negative 6, which means that the x value is negative 2 again. So negative 2 is the x value. And we need to get the y value. I'm going to do it the same way I did last time. I'm going to choose to use the equation that was in y form. Y equals the opposite of whatever x is, then add 3. And the x is a negative 2. And then the opposite of a negative 2, well, that's a positive 2. And then we'll bring down that 3. And that gets me that y equals 5. I don't know why I did that in the other color. So according to that, it's also 2, 5. All right, now we'll do our check. So we'll use the less organized equation, but I'm going to substitute the same way. I'm going to put the x in for the x and the y in for the y. So 2 times whatever x is minus the y value is supposed to equal negative 9. If that's true, we're in good shape. So I had negative 2 for x and 5 for y. And so that's negative 4 minus 5 equals negative 9. And yep, negative 9 equals negative 9. So it checks. So that means this is, in fact, our point of intersection. Okay, guys, that's it. That's substitution. I'm going to send you off and let you do some practice. Good luck.